Thanks to Brilliant for supporting this SciShow video. Brilliant is offering a 30-day free trial and 20% off an annual premium subscription for people who sign up at brilliant.org/SciShow. In 1979, the English astronomer Fred Hoyle said outer space was only an hour's drive away if your car could go straight upwards. And sure, that's technically true, but the rest of space is pretty darn remote. It would take that very same car 400 billion hours to reach the next star over. So it's almost impossible for scientists to get up close and personal with interstellar objects, limiting our understanding of the greater universe. But every so often, the rest of the universe comes to us. Our solar system gets an interstellar visitor. And maybe, just maybe, that visitor might stick around. In October 2017, researchers in Hawaii caught sight of something zooming across the night sky. And the way this body was zooming across the sky was highly unusual, because based on its trajectory, it didn't have an orbit that we'd expect from an asteroid or a comet. See, basically every body in our solar system goes around the sun in a path that's shaped like a squash circle. But this orbit was hyperbolic. It looked a lot more like the path a spacecraft would take on a voyage out into deep space. So to scientists analyzing this strange new body, a hyperbolic orbit meant one thing. This thing didn't come from our solar system. It wasn't a Kryptonian spaceship due to collide with a patch of Kansas farmland, of course, but it was a visitor from elsewhere in the Milky Way. And by analyzing its trajectory, astronomers determined that it was merely passing through our solar system. It was already on its way out and would never be coming back. Eventually, this object got an official name, Oumuamua. It also got an official designation, 1I, because it was the very first interstellar object, or ISO, that humanity had definitively spotted. And boy, did people have thoughts about Oumuamua. Was it an alien spacecraft up to some nefarious business, or was it a much more boring hunk of plain old rock? All signs point to the latter, but astronomers might take umbrage with my calling an interstellar rock boring. After all, ISOs are pieces of somewhere else in the universe, delivered to our cosmic doorstep. That makes them an invaluable resource for figuring out if our solar system is something run-of-the-mill, or actually a massive weirdo and we just don't know it yet. Maybe we just think other solar systems are built out of the same stuff as ours, because this is what we're living with. Oumuamua is already further from the sun than Uranus is, and should reach Neptune's orbit in late 2024. So it's too far out for astronomers to continue collecting data on. But that doesn't mean they can't work the data they do have to update our vision of this interstellar visitor. For example, they initially thought Oumuamua was long and roughly cylindrical, kind of like a cigar. But it turns out it's probably more of a pancake shape. And rather than being a comet or an asteroid, some researchers hypothesize that it's actually a giant hunk of nitrogen ice that chipped off a frigid Pluto-like exoplanet millions of years ago. Oumuamua may be the first recognized ISO, but it isn't the last. Back in 2019, an amateur astronomer discovered Comet Borisov, also known as 2I. And just like with Oumuamua, it was its hyperbolic orbit that tipped us off about its interstellar origins. As you might have guessed, Comet Borisov is, well, a comet. It's got all the hallmarks we'd expect, the fuzzy halo-like shape around the main body and a tail in its wake. But there's something just a bit odd about it too. It has way more carbon monoxide gas than we'd expect, and more than we'd seen in any other comet that got within 300 million kilometers of the sun. And that's not just a fun fact. It actually gives us hints about where Borisov came from. We don't know its exact origins, but the amount of the carbon monoxide suggests it was made somewhere very cold and rich in carbon. It probably formed in the outskirts of its home system, somewhere where it was cold enough for the carbon monoxide to freeze. And then it stayed that cold until it got here. Oumuamua and Comet Borisov are two examples of interstellar tourists. objects that merely pass through our solar system. But we're pretty sure our system is home to another type of ISO, interstellar immigrants, that wind up settling down here. Unfortunately, we don't have absolute confirmation of any interstellar immigrants the way we do tourists, but we do have some pretty solid candidates. First up is asteroid 514107, aka Oumuamua. It shares an orbit with Jupiter, but goes around the Sun backwards compared to all the major bodies in the solar system and to most of the minor ones too. And according to research, it appears to have been flexing that weird orbit for the last 4.5 billion years. It's not definite proof, but that backwards motion is pretty solid evidence that Oumuamua came from beyond our solar system. And if that's true, it likely moved here right at the very beginning. But that's not all. Another ISO candidate is Comet Hyakutake, or the Great Comet of 1996. In this case, it's not the orbit that suggests it has an interstellar origin, but the chemical composition. See, Hyakutake seems to have a lot of ethane gas and comparatively little methane gas, which might not sound like a big deal to you or me, but astronomers don't normally see that ratio in comets that are native to our system. So maybe this one just happens to have an unusual composition. Maybe a closer look at other comets will eventually reveal Hyakutake isn't all that unusual after all. Or maybe it comes from a different stellar system, where that particular ethane-methane mix is totally normal. We'll never know for sure if either of these space rocks really is an ISO, but the hunt for interstellar immigrants hasn't stopped there. It's a pretty difficult hunt though, because most interstellar asteroids and comets are probably pretty small. And while we do have some hints as to what types of orbits we should be looking for, it's really hard to track the trajectory of something that's small unless it's super close to Earth. So it's sort of like our solar system's version of Where's Waldo? And that's not all. Earth may also be getting struck by interstellar meteors that are even smaller. Unfortunately, the actual evidence for this is even spottier, because a meteor's extra small size makes it more susceptible to gravitational pulls of other bodies in our solar system. In other words, a meteor that appears to have a hyperbolic orbit could have been knocked into that shape by getting too close to, like, Saturn or something. No interstellar origin needed. But we can be reasonably sure that our solar system is home to at least some interstellar immigrants. The exact estimate varies from paper to paper, but our solar system could host thousands of ISOs at any given time. Most of these will move on eventually, but the time they spend here could vary from a few decades to a few million years. And from my limited human perspective, that sounds like more than tourism. And while astronomers continue their search for the first definitive interstellar immigrant, we can all wave goodbye to a space rock that was born in our solar system, but is packing its proverbial bags to emigrate right now. Back in 1980, Comet Boel had a gravitational run-in with Jupiter, and that run-in gave the rock a big enough speed boost for its orbit to turn hyperbolic. So it's been shooting off toward interstellar space ever since. But if you want to wish it a bon voyage, you shouldn't keep waving until it's finally gone. Astronomers often describe the Voyager 1 probe as having encountered interstellar space, but it's still a good 3 centuries from entering the Oort cloud, the outermost boonies of our solar system. And Comet Boel won't hit Voyager 1's current distance record until the next century rolls around. But when it eventually leaves home, maybe it'll bring a little bit of our solar system to some far-flung aliens and teach them about where it came from. If you want to learn more about how stuff moves around in space, you'll want to understand vectors and other math concepts. After all, vectors are just descriptions of movement through space. And Brilliant has tons of content all about them. You know Brilliant, the interactive online learning platform with thousands of lessons in science, computer science, and math. They offer case studies, puzzles, and tons of unique ways to help you engage with each topic. Brilliant teaches you to be a problem solver, not a memorizer. And that may sound like a big concept to learn, but with Brilliant, you can get there by learning a little bit it every day. Their courses range from newbie to advanced math, so you'll be sure to find something at your level no matter what that starting point might be. Then, after spending some time with Brilliant, even a newbie can make their way to advanced levels. You can get started along that path at brilliant.org/SciShow, or the link in the description down below. That link also gives people who sign up 20% off an annual premium Brilliant subscription, and you'll get your first 30 days for free. Thanks to Brilliant for supporting this SciShow video.